can start recording. Okay. So yeah, because it's a stream, but also kind of an explanation video, I will start with the basics. So currently, our library are split in different functionality. So if you go to the old documentation, which I should actually update by then, we have well, not six, 7 library, well actually 8 now. So there is Mitotil, SeedUtil, NoiseUtil, TerrainUtil, FeatureUtil, Biomaterial, Chunk Reversal, and LatticeG. So to be actually clear, that's actually the graph of dependencies. So we have the main crate Matotil, which provide like utility for mat and stuff which are used mainly in reversal stuff. Then this crate is imported in most stuff. When I'm saying crate, actually I mean library, just because I'm coming from a Rust background, so crate library is the same thing for me. So library. SeedUtil is a library with the Java LCG. Then MCUtil is with everything which is Minecraft related. So we put everything in that, which is quite annoying because this library takes a while to compile most of the time. But when it's actually a bit compiled, then actually it's fast. Then there is NoiseUtil, which well, I implement all the noise related stuff in Minecraft. So that will be Perlen, Simplex, Double Perlen, that would be the Octave. There will be a lot of stuff. Then there is Biomaterial, which is mostly the biome stack, but there is also the new biome for the Nether, for the 1.18 biomes, and there is a ton of utility to actually get like some noise related, like for flower noise or stuff like that. So everything that is mainly used in the biome step and related to temperature, humidity, and stuff like that are in biomaterials. Terrainutils is to get the shape of the terrain, so that will be mostly leveraging the NoiseUtil crate library, and it will create the different height and also allow you to generate a full column or full chunk or stuff like that. Then there is FeatureUtils, which is the final library because it incorporates everything. So technically, if you import FeatureUtil with every transitive, and technically you have everything, but we will see that there is actually a better alternative. And with FeatureUtil, we have everything in it. So we have the structure, we have the decorator, we have the features, we have spawn point, we have slime chunk, we have loot, we have well, structure generation, like the template and the layout of some structure or features. We have well, in feature we have the ore generation now and stuff like that. And then there's 2 libraries which are on the side, which are chunk random reversal, which contain all the utility to actually reverse like carver seed, decorator seed, and stuff which are, well, they are called hash. So they are a way to actually get from some type of input to some output, which is generally a seed, and we can reverse from the output the seed to the input, which are generally coordinate or coordinate and seed and stuff like that. And LatticeG is a general purpose library to actually reverse any LCG and technically other kind of a pseudo random generator, and it's mainly used to actually efficiently solve some problem or some optimization problem. So, for example, if you want to say that there is n call which equal to some value, like for the dungeon or for the 12 eyes or something like that, then we can use LatticeG to actually reverse that efficiently. So that's the structure of our current library. So if you want to find them, you go on GitHub, of course. Then you will go on Captain Wutax, which is the guy who created actually all the repository, but I'm actually contributing on it. So I'm active maintainer on it, and you will see that there is also utility, well, also utils on its profile. There is also SeedFinding, which is another user, maybe not in user, which is also library, but they are mostly in Rust or other language. And yeah, you can see all of them are here. So everyone, well, there's only me, but actually there is way more people in that we just didn't activate the visibility. And there is also FNCC, which was made by Fred. Oh, I don't recall who made it. He changed his name too many times. Anyway, so there is all the stuff. You can actually get Captain Utak's library and see everything which is needed. Oh, the link is not working. Nice, wonderful. So yeah, you can get a lot of stuff which are needed. So yeah, there is a list of all of them, and then there is like stuff. Yeah. Anyway, let's go back to actually each library and go in order and to see how you can actually provide help and provide some stuff on it. So Matutil is frozen, which means that actually we don't accept any PR on it and we don't plan actually to change anything. So there's no readme sadly, but we actually don't need any. So there is also arithmetic stuff, so component stuff, so matrix, vector, so decomposition, so LU decomposition, which is useful for Gauss Jordan or stuff like that. There is Lagrange Gauss, which is mainly useful for computing some set of point in a grid. Maybe we'll come that to later, but anyway, it's not really important. So there is a small implementation of LLL here, which is not the best one, but it's a one. There's Gauss Jordan, Graham Schmidt, Ansel, which is used for lifting, and there is some utility, some combinatorics, so small stuff like permutation and stuff like that. And there is mat, so you can get like the mask here. You have the inverse, you have the mean, well, everything that you usually need. So there is a clamp utility, for example, here, and stuff like that. So yeah, that's utility for the mat. You usually don't use them, but it's useful to know that they exist because sometimes you actually want to create like a matrix or a vector, and you can actually create it with that, and they are backed um, with native types, so they are usually fast. So that's Matutil. We can close it because we will not go in detail about it anymore. So next one is Sedutil. So Sedutil is also frozen because we usually don't tend to change anything on it. It's mainly the LCG on it, in particular the Java LCG. So you will have a general implementation of a LCG class. So LCG class is mostly a multiplayer, nadent and a modulus, and the formula is as such as uh, the seed times the multiplier plus addend modulus the modulus. So yeah, and there is like the combine utility and stuff like that, everything which is in here. There is also the discrete log, which is useful for reversing stuff. You won't use it, but we actually use it a lot in chunk random reversal, for example. And here you have the main implementation of the Java random. So here you have a general implementation of random and Java random, which use Java LCG here. And you have the utility like a next int, next float, next double, shuffle. So if you want to shuffle a list with a run, then there is here the shuffle implementation. You can set a seed. You can set a seed without scrambling it, because if you do, then if you don't, then well, you have only the seed and not the seed times well XOR the Java multiplier, which could be thrown you off when you're actually working with that stuff. Then there is the next, which is the main core method, the next float, next long, and well, every utility you want. And there is also a debugger, so you can actually cast the JRun as a debugger, and you can get actually all the advanced call, the global counter, next int, and so on. So that's useful for debugging. So you usually you have like one instance of JRun, you pass around in all method, and you can cast the first one as a debugger, and then you can actually get all the information about it, which is useful when debugging. And there is also the combined JRun, so that's for combining different LCG efficiently. So yeah, so that one we will not go through it because it's frozen, it will not change. It's a small utility which is mostly for the Java random. Next one, MCUtil. So that one is actually a big one, and because it's big, we will spend maybe a bit of time on it. So the first thing you will see is the README usually, and the README you will see that we support NBT, seed and hash used in Minecraft, jigsaw placement, Minecraft blocks, some math position, bounding blocks and stuff like that, and we have also Minecraft version in it. So you will see that we have scripts which are used to actually generate like a list of block or version for different Minecraft. Then you have different sub modules. So the block one, which is all the blocks. So here you have a list of all the possible blocks. So that's just the block implementation, but all the blocks are in blocks. So all of them are here. So there is about 1,000 of them, and each of them have a specific implementation, which is backed by what we call a feature map. And well, in this case, it's actually a bit different, but so you can actually see if some block change between version. For example, the ID change in 1.14 and 1.17 and stuff like that. So everything is here. There is a block state, so that's to actually mimic what Minecraft does, which is adding NBT compound on a block. So we don't actually use that one, but if you want to use it, then yeah, feel free to use it. A tile is mostly used in the structure placement. I don't use it anymore because I mean it's quite empty. It's not really useful. Maybe I will go around and modify it anyway. Block palette is the palette you will have in the NBT file. So if you open, for example, NBT here, you will see that you have a palette which contains also block ID and the name. And the block ID are used in the block. So here you have state 0, which correspond, if you go in the palette, to cobblestone. So that means that you don't actually store unnecessary stuff, you only store an index and then refer to the index in the block. So that's made the NBT format a bit compact. So the block palette is for that. And here you have the full implementation of each block with the feature map and so on. Then you have the gen part, so that one is for the jigsaw. So they are mostly utilities. They are not complete because we are actually moving a lot of stuff in jigsaw. So yeah, but you can actually, if you look at the test, load a full NBT and modify it as a jigsaw. So yeah, that's one thing. There is a structure piece which is mostly used for structure placement in the loot part in Iterator. We will see that later on. And yeah. Then you have the NBT, so that's to actually read the NBT file. So we support a full NBT file. We can read it as a, so it's a gzip. We can actually read it and unzip it and then compute all the tag and so on. So there is a full implementation of the NBT library in MCUtil. Then you have all the stuff for the net handler. So that's a byte buffer, which is useful to well do everything which is network related. Then there is a run class. The run class is mostly used to host chunk run. So chunk run is extending the Java random, so it's a Java LCG, but it actually gives you also utility to set all the seed. So I highly recommend to actually read all the documentation here, because you will get why how to use actually each of the method here. So one notable one is population seed, I guess, because this one is set at well, population stage, and is mostly used after with all the structure calling it. So usually you set the population seed, and then you get a seed and you use it in the decorator seed. The terrain seed is mostly used for the structure, so structure placement is done with the terrain seed. Decorator seed, like I said, is used after the population seed, and is used, for example, for loot, but also for small block or modification of blocks in a structure. Then so there is multiple one for set decorator seed depending of what you want. For example, you could provide the index and step, or you could combine them directly in a salt, or you could provide word seed, block, and so on to actually so set the population seed first, then the decoration seed. So that one does both of them at the same time. This one is just with the salt instead of index and step. Then you have the cover seed. The cover seed is mostly used when a structure or feature is instantiated the first time. So cover seed is set, but it's also used for ravine, cave, mineshaft, stronghold, a lot of stuff like that. Region seed is used for structure placement again. It's to get actually the structure in a region. The Wixid, we don't use it much because it's deprecated now. It was used by the Nether Fortress back then, and now it's used for Pillager Outpost, but it actually changed in 1.18, so yeah. Slime Seed is used for Slime Chunk. As you can see, there is we had to suppress some stuff because it's actually not correctly in casting some stuff, so we had to explicitly set it. And then there is position seed, so this is used mostly to get a block type. So usually you set it by block, so by position, and you get a block random in a list, and that will be the block. So that can be used, for example, for stronghold, moss, or stuff like that. Yeah, and base stone is used in 1.17 plus, and it's mostly used for as the turf for the new cave blocks. And you have also utility to get a random in a collection, a list, or something like that. So you get a random element of a list. And also there is a debugger, so if you want to actually debug a chunk run, you can actually call as debugger and then get a debugger. So if you look at the top, there is as chunk run debugger, which gives you actually a debugger on it, and you can actually get everything about it, which is mostly the call and how they are advanced and stuff like that. And all the seed here are the internal stuff. So here actually you have one which is not exposed in Chunk-Run, which is the pillar seed, which is used in the end. So if you want to use them, they are here. And here they are mostly well, all the implementation of them. Seed mixer is one in particular, which is the one used for the Biomaterial 1.17, and they are so the QLCG, which is MMX, which is so in 64-bit instead of 48-bit, and yeah, it uses a polynomial in of a degree 2, which expand to a degree 4. Yeah, here you can actually see a lot of information and stuff like that. Structure seed, there are structure seed. So here you actually one which is interesting method, which is called two random word seed. So you can actually return the possible value of the upper bit, so they are actually generated from a next on call. So this will return between 0 and 2 seed. So this list is actually 0 to 2, and this actually use an efficient implementation of the next long reversal, which is something made by Matthew. So this is useful when you actually want to, from a structure seed, get a corresponding word seed, which would generate if you actually didn't impute any seed in the box when generating a word. And you can also get all the word seeds, so all the sister seed. We call them sister seed because you just add 2 to the power 48 to the structure seed each time. So you actually change only the 16 upper bit, and yeah, you get a Iterator here, and also there's a pillar seed which actually gives you the part of the pillar seed. Yeah, so yeah, it is. Then you have the state. So in state you have the dimension. So dimensions, I have 3 of them for now. So overworld, never end, and you can get a utility for each of them. In the version, we will go from there here first. There is also version and their date and stuff like that. So from 1.17.1, which is the latest, to the first stable one, which is alpha 1.04. And yeah, so 10 years, well, 11 years ago actually. No, yeah, actually it's 11 years and 12 days. No, yeah. So yeah, quite old, and you have a lot of stuff like is newer than to compare, is between to compare between version. You can see if it's newer or older. You can find if it's a release, alpha, beta. You can get, for example, the latest version or the oldest version. So that could be useful when you want something which is always up to date, because we make sure that actually everything is supported for every version. So you can, starting from 1.14, everything below is well, depending of the library. And yeah, then you have an exception, so that's useful when you don't when we want to indicate that this is not supported. And this is version map, which is used to actually set stuff depending of a certain version. So we only have them when we get them from one version, and not all the entries, or have to make a switch case or stuff like that. So we dump everything in a version map, and then we can actually say, for example, version map from 1.13 to 1.16 is the same. So 1.13 I had an entry, and 1.16 I made another entry. So for all the number between, it will only pick up the 1.13, and for all above 1.16 it will pick up the stuff in 1.17, 1.18, and so on and so on. Yeah, so that's useful when you don't want to say for each version, but only say like a point where it changed. So use the version map for that. Then there is a utility. So the utility, there's a block. So block box, which is actually the bounding box. So bounding box is defined by a 6 number or 3 pair if you want, which are the min and max on each axis, and so that define a box. You have utility like get bounding box, which depend of a few parameter, which is a lot used in the code for jigsaw or structure placement. You can mirror, you can offset, you can move, you can get inside, you can rotate, or can intersect. You can see, for example, if it is inside the bounding box in 2D or 3D. You can make sure that it actually two boxes are merged into one, and so on. You can also get the direction. So direction is backed by actually the rotation. And you have like down, up, north, south, west, and east, which are the six direction in 3D. And you can mostly get everything you want, like the opposite, rotation, get a random inside the value of direction, and so on. The mirror, which is to say if you want to rotate, to mirror something along a certain axis, a certain direction actually, and yeah, you can mirror with that. And rotation, which is the base class of block direction, and this is to rotate stuff. In the data, you have a lot of stuff. So you have the identifier, which is used to identify like blocks, structure. A lot of stuff in Minecraft are using an identifier. So there is always a namespace, which is usually Minecraft, and then there is the actual path, which is the name of the object, enchantment, book, well, anything. Then you have a pair, which is so the pair is a two element, and they are concatenated into one object. So that allows you not create like a list or like a tuple or stuff like that. So actually, it's a tuple implementation because in Java you don't have tuple or triplet or stuff like that. So this is a implementation of tuple. You have the triplet implementation, so for 3 element. Then you have the quad elements for, well, a quad, and that's mostly it. And if you want to combine more, usually you do like a quad of pair or quad of triplet or something like that. I don't recommend using much of those. I mean, it's only when you want to return some kind of result, which you know because it will be in separate part. Then you return a quad or triplet or pair. But usually it's better to create like an object if you want to have like utility on it and stuff like that. Then you have the seed iterator. So that one is for mainly making an iterator between two bounds, and you can provide a mapper and stuff like that. You have the spiral iterator, which was made by Xvel. Um, so it's mainly to iterate in a spiral starting from center position until the bound. Then there is a string inertia. So this one is used for getting a string which will match 32-bit seed. So that's if you input, for example, a string in Minecraft, it's converted to a 32-bit seed, and from that seed we can actually recover, well, not exactly the string, but the possible string which would make that 32-bit seed. So this utility is for that. So you call it from the unhash here, and you give it the hash code, which is 32 bits, some kind of config. So if you want, for example, having some minimum character, max character, and so on, and the predicate, which is until it match, like for example, like almost this string or as this word in it, then until that you continue, and when it you actually return the result. So then there is a thread pool. So this one is to actually iterate through stuff with all your thread and all your processor. Usually you provide like a task or a consumer here, an action, and then you can actually send stuff in it. And then you have the mat utility. So there is a distance metric. So that's the 4 of them which are used in Minecraft. So Chebyshev, which is mostly the maximum of each axis. The Manhattan distance, which is just a staircase until the some point. The Euclidean, which is a direct line to some point. The Euclidean square, which is actually the real distance. Um, well, it's actually used when you want to optimize stuff, because usually when you compute stuff, you actually know the radius, so you can actually square the radius, which is just a multiplication, and it's faster than computing the square root. So usually you do Euclidean square is superior or equal to radius times radius. Then there is a next long reverser. So that one we saw, it's actually to reverse the next long. The vector 3e, which is used to back off all the position. It's mostly oh, a, a class, a class with 3 int, so x, y, and z, and you have all of them. And now you have the position, so block position, bpos for short. You have also utility to add, subtract, shift left, shift right, add, subtract, and so on. You have to remember that mostly the add, subtract, and so on are returning a new object. and not actually the old object. So you should be always storing the new object in the same object if you want to update it, and so on, because else it will not be updated. Chunk position, so CPOS, that one is where we have the chunk position. So chunk position is only defined with two numbers, X and Z, and they are usually only, so you divide by 16 the block position to get the chunk position. Yeah, there is so many chunk position in world. Then you have the region position. So this one is actually determined from a region size, which is depending of each structure, and you can actually change the region size if you want to actually resize it to a different region. And there is also GT, yeah, to do so. So that's about it for MCUtil. I think I spent a lot of time on it, but I want everyone to be aware of everything that exists in it. Yeah. So if you have any question, I think it will be the time for MCUtil. Else I will go to the next one, which is noise util. If everyone is not just asleep, I guess there is no question. We'll let a few. Okay, no question. Yeah. So noise util. This. So noise util. If you look at the README, you will see that it actually tell you that it's an efficient library to simulate parallel and simplex noise. So what you need to know is you have a noise implementation. So a noise actually is just 3 next double to get X, Y, and Z position, which will be the offset. Then there is a permutation table of 256 byte. So actually it's U8. So 0 to 255. And you get them through a random next-in call. So because of random next-in actually can skip, it's actually not possible to compute it at once. You actually need to compute the next-in for each, or you need to use a lookup table if you want to compute the skip and so on. And yeah, this table actually define a noise. So from this table you actually get the noise. That's all you need to know. And because you have 256 next int, you actually have enough entropy to be sure that you are fine enough to get enough random value. Then you have the interface for noise sampler. So usually you have a sample method, so x, y, and then you have two number which are depending of what you call, could be z or could be offset or magnification on x and z. Then you have the parallel and simplex implementation. So parallel noise use what we call the gradient. So it computes for each of the 8 points of a cube a gradient, and then compute and get the point inside to actually get the final value. If you want to know more about that, I think I made a video about it, so I would recommend check it out. Anyway, it's not really important. You just need to know that it's here and it's implemented. Then you have the Octave implementation. So the Octave implementation is combining different parallel noise sampler into one big sampler, which has like different amplitude for each of the parallel sampler. So they, for example, you have like one noise to make the whole shape of a mountain. Then you have one noise to make the boulder. Then one noise to make the stone, and so on. So this one is yeah, the sampler. So there's a lot of utility to call them. It's a bit messy if you are not familiar with it. LaTCG is a different library which is on is yeah, it's not really part of the library, but it can be used in conjunction of them to actually be useful. Then you have the Simplex Noise. So Simplex is actually a faster implementation of parallel noise, and it's used to, it's actually sample in a triangle, a point inside the triangle, and yeah, return that point, and then you actually sample it and get a value. And that one you can actually also get a Octave version, which is the same as the Perlin one, but a bit different in how they actually handle everything. Anyway, those are the implementation of the noise. You only use Octave and Perlin noise sampler usually. You don't use raw Perlin and Simplex noise sampler. And you have also the double Perlin noise, which is a version which use two Perlin noise and combine them into one. This is notably used nowadays to make the Never, and in 1.18 to make actually the overworld biomes. And you have Matador with some utilities, so yeah. Anyway, we are done with noise util. It was really short, but I mean, there is not much you need to know about that one. The next one is Biomaterial. So that one is a big one because it actually supports every generator starting from actually beta now, and well, officially it's release 1.0, but I think it's about from beta and up to 1.17.1. Actually, I need to change everything here, and you have a quick explanation of how the biome work here. You have how to use it if you want to actually import everything separately. But again, we can actually use, for example, the seed library to actually import everything for you. And there is a utility to get from every biome source. So usually you declare biome source of the dimension, the version, and your seed, and then you can call get biome, which is a standard interface, and yeah, you can call it for the overall, never, and end, and get everything. We have also something which is called the surface, which is implemented for each biome. So for each biome, you can actually modify the block in a column. So usually you get the column from the terrain util, and you can modify the block depending of the biome type to actually get a different type of blocks. I said modifies the biome, modifies the block depending of the biome, and you get different block type depending of the biomes. So yeah, you have the list of all the biome here with everything in it. You have a device which is useful, for example, for computing quick seed like a mushroom and stuff like that. So because it uses a quad LCG, there is actually stuff you can do on the upper bits to actually get it faster. So in Biomaterial, yeah, you can actually compute a lot of stuff really fast. So usually you call biome device and you specify your condition. So you have also restriction in here. For example, I want only cold forest. I call forest on some region and say, yeah, I want cold forest here, here, and here, and I will get also seed which will give you cold forest in here fastly, not with iterating all the seed and so on. It will only give you the seed which match the precondition. So it's actually optimization problem which is solved by the biome device. The layer, there are also layers which are used in biome generation, so you can look at them if you want. They are usually quite simple. They have only like a simple implementation, but some are much more complex because they need to actually implement for each of the different version. So yeah, we can support beta apparently. Yeah, I did beta a few months ago, I think. Anyway, so if you go in overworld biome source, you will get the latest version which can be used. So everything after beta 1.8.1 can be used. And here you have the biome stack as it is generated since 1.0 and until 1.17. And yeah, you can sample stuff in it. Now it will change to what we have in the Never biome source, which is the multi-noise layer, which is a bit different because it uses a double parent noise. And we actually implemented recently the multi-noise layer for 1.18, so that one will be useful for later on. And you can actually supply your own generation layer to the multi-noise biome source if you want to. And you also have the different noise for the static noise source. So you have the temperature noise, the frozen temperature noise, a biome info noise, which is used for flowers, for example. And you have the different noise which are used for the surface. So those one are cached because they are actually static. So they only depend, for example, of a seed which is fixed and the position. So we cache them on a static instance. So for each time you sample it, then it uses a cache mostly and will store the result if it's not in the cache. Of course, that's not the case, for example, for the biome source. The biome source, you need to create an object, and the cache is binding to the object. So each of the biome source implements a layer biome source, which implements an in biome layer, which actually has a cache in it. So each of the layer has a cache, and it can store, well, initially 1000, but actually it increases with time and can be reduced and so on. So everything is managed automatically, but you have a cache to actually sample everything fastly. So you are not at any time stuck with like I need to recompute everything. Just need to recompute some stuff, so it's a bit faster. Okay, so we are done with biomaterials. Any question on that? I think not. So let's go to Terranutils. Terranutils is quite simple. There is only yeah those utility. So there is the end, the never, and the overword. So each of those are defined with parameters, and they implement some stuff depending on version, of course, because some versions are different. Currently, the current generation is working from 1.8 to 1.17. 1.18 will come later on. And you can also call terrain generator off, specify either the dimension or just the biome source. And from the biome source, you can generate, well, the terrain generator and call then so the different method. So usually you call get height on ground or in ground to get the height on the prediction column, or you could get the column, or you could get the biome column, so with the block replaced depending on the biome, or you could get the bedrock column, which is the biome column with the bedrock at the bottom. This one is a bit particular because you need to generate the full chunk, so it's a bit slower to actually do it. And yeah, so here you have the noise setting, which is useful if you want to implement different versions and so on. And the surface generator is the main implementation. So this one is actually the core part. So for each, yeah, bedrock generation. No, not bedrock, Minecraft bedrock. The bedrock of the bottom of the world, which is a bit different, is implemented. So yeah, bedrock block. So yeah, okay, just to be sure. That's actually not correct, I think. Oh, my bad. Actually, apply a bedrock. Okay, so the bedrock is done with the next int, and because it's done on a share object which is coming from the column before, you need to generate a full chunk before to get actually the offset, and you cannot compute this offset because it depends actually of the height of different column and so on, and different biome. So yeah, it's a bit annoying. The bedrock depend of so much stuff above it. So yeah, you need to generate the full chunk, then you can generate the bedrock for the roof and the floor. So yeah, that's supported. Anyway, so first generator, there's also different utility to get the column. So there is a sample noise, the sample noise level, the column, and so on. No, so if you call get biome column, you will get only the biome the block replaced with the biome counterpart. So usually when you get the column, you will get only 3 blocks. So default block, default fluid, and air. Maybe it could be 2 blocks if the default fluid is air, for example. But yeah, because that's how it is generated. There's only, like, for example, snow, stone, and water, and air in in an overworld chunk generation. But if you replace with biome, you get actually grass, you get gravel, you get a lot of different block which are depending of the biome, and then you can actually add bedrock, and yeah, and then everything else which you see in a normal world, like some like the ore, or like the pocket of dirt or stuff like that, all of that is implemented with decorators. So in effect, Terran Utils is generating a full world, but it's not generating the decoration part. It's generating the dull world, which is like the bulk of the world. Yeah. So here you have also test, and I think I didn't included any example in README. See, yeah. So here you can actually see all the method which can be used here. Yeah, get bedrock column gives the most accurate column, and actually once you call it, you are sure that actually for all the chunk it has been cached. So all the column in the chunk has been cached, so you can actually generate any column in that chunk, and it will be at 0 cost. So the first column has a huge cost, but all of the subsequent will be at no cost because they will be cached. Okay, so now we are done with Terran util. We can go to the final library, which is FeatureUtils. Maybe we will go through chunk random reversal and latticg later on, but I don't think they are necessary. Anyway, FeatureUtil, I think that's the main part which a lot of people are interested in. So sorry for 45 minutes of me talking about the overall library, but that was needed because I needed to explain a lot of stuff. So I want first to show this drawing. So in Minecraft we have something called features. So in features we have the decorators, which are the ores, the dungeons, the trees, and gateway, the dirt patch, a lot of stuff actually are decorators. You have the structure, which are the main, well, they could be actually decorators, but they are actually different other stuff, which are big structures, which are placed in some part of the world, and because they are particular, they actually place only in some region, so they will not overlap. Get in the same region more than once. So, for example, if you open mind map and open a world, then shows a grid, you will see that if I activate the structure seed mode, you will get only one type of structure per region size. So actually, not all regions are equal. So for example, for bear treasure, they are only one chunk wide. So you can actually get more than one in a 32 chunk region. But for most of the structure, it's a 32 chunk region. So you will get only one per region. So yeah, you have one. Some other structure have larger region or smaller region. For example, Ocean Monument, NCT, for example, also. You can clearly see the pattern here for NCT, for example. And Gateway is not region dependent, so as you can see, you don't see a pattern. But for NCT, you can clearly see some pattern. And especially if I zoom and show you the grid, you can clearly see a pattern. Of course, the region is a bit smaller for NCT. For the Nether, you also see the pattern, so you will see some straight line here, for example. There is actually a thing which is a bit different. In the Nether, the structure can only generate in some region exclusive. So for example, Bastion Remnant and Fortress are exclusive, so they will not generate in the same region size. But else, yeah, it's the same. It's region, so we'll only generate once in a region. Of course, the region size is smaller here, so it's not representative. But anyway, yeah. So you will always see some pattern in how the structure are spread across seeds. So in structure, you have the legacy structure, which are the mine shafts, the stronghold. This one actually don't use a region. And there is a region structure which we talk about. So there is in them the uniform structure. So those are actually in a well in a pattern, a square pattern, and you have a triangular structure which are actually mostly spread in a triangular pattern. So they are a bit different. And you have other stuff like the slime chunk, you have a spawn chunk, spawn point. You have a lot of stuff which are considered feature, but they are not actually like something you see. They are mostly a state. So yeah. Okay. So now that we are fixed on that, we can see that feature tiers is spread across 4 different modules. The first one is a structure one. So this one is the most historic one. It contains all the different region structure here and the generator for all the different structure which are supported. So here you can generate all the pieces, for example, for a specific structure. So NCT, Rune Portal, Shipwreck, Stronghold, Village, and so on. They are all registered in generator. So here you can all get them with the registry. So you can get all of them. Well, all of them which are supported. And through the generator, you can actually generate them with only a turn generator, the chunk, and a chunk round if you want to pass it for optimization, or if you want to just give the word seed, then it will compute a turn generator. I don't recommend using it because it will not be cached. So usually you want to have the object stay in your heap because you want to get it well cached and use the cache. But if you just want to generate it quickly and don't want to create an object and store it and so on, you can just call this one, which will create a temporary object and then free it when it exits. And you also can get all the possible loot, because loot is implemented with the structure generator. If you don't have a structure generator, you can not get the loot, because loot depends on actually the position, the specific position of the chest in the chunk to actually generate. And here you have all the pieces, so pieces for stronghold, the village, and so on. So yeah, very useful to generate the structure. So each of the structure implement extend as an interface which is coming from a lot of stuff. So as I said, the drawing help a lot, but the main class is what we call a feature, which implements a generation context, which can get you like a terrain generator and biome source for a specific feature, which is useful when you actually don't want to create the object. Just call get context and it will get you the context. So yeah, that's a nice way to actually create them. Anyway, the feature, so we have 3 main methods which are abstract here. So can start, which gives you the starting position. Well, actually, tell you if you can start in a specific position. So this position it gives you with a data, and this one is, for example, for the region. It tells you if structure can be generated in that specific area. But for feature, it's also for decorator is also valid, because you can actually get a decorator which will not generate at some position. Can spawn actually use a biome to check if the biome requirements are met, and can generate check if actually the terrain is able to generate that structure or feature or decorator. Anyway, feature because it's in the feature. And also you can define a data. So the data should implement the test start, test biome, and test generate, which allow you to actually test start and biome and generation at some place. So that's useful with you usually set as the data and then you call this utility if you want, or you just call constart and conspawn with the data as an object. And yeah, that's about it for the feature. So the feature is then used in different stuff. So the main one is structure, which we saw earlier as the historic one. So you get a list of all the possible structure here with your name, and you can actually get the specific biome which are attached to this structure. So they will only generate in this biome. You can also get my bad, actually this is not for that. This is actually the biome in which it generated from. So this is actually where it's stored. So we store actually the biome when you call const spawn. It actually stores the biome here. Anyway, yeah. So you can check if it's valid or stuff like that. So yeah, a lot of utilities. Then you have the different type of structure. So you have the uniform one. So you can get in region. So this one you provide the structure seed, which is a lower 48 bit, the region X and Z, and then you actually get the positions, chunk position in that region for that structure. And this one is actually also implemented for triangular structure, and because it comes from the region structure interface, which actually get you a get and region abstract. Each of the feature can actually also have a config. So the config is important because you can specify a salt, can specify some stuff like other stuff like separation for structure, but for decorator it could be anything really. So yeah, the feature interface is really useful. Well, not interface but abstract, because you can give it a config and a data to store some stuff. So in data you store stuff, in config you actually store static information which will be used to actually say, well, some method should work depending of version. So a salt, so example, ask what is a salt. So a salt is actually something which is used in the generation stage to actually identify uniquely a decorator, or well, actually it's a feature, but anyway, it's to identify uniquely something. So it's used a lot in Minecraft, but it's also used for password, for example. So for example, a password, you usually encrypt it as such. So you have the password as plain text, then you add a salt, so salt, and then you encrypt everything like so. And because you encrypt password plus salt, someone which needs to decrypt a lot of password then needs to actually cannot just call decrypt each time. They need to call decrypt for all the existing salt. And this is actually quite annoying if you want to do so, because there is a lot of salt, so it's actually adding more entropy to the possible unique password. And for that, so the analogy is the same for the seed. So you have encrypt seed plus a salt, and yeah, so each feature has its own salt, which is used in the population stage or decoration stage to actually set a single seed, which depend on the structure seed, of course. Yeah, yeah, so salt is always different for each password. You always store a different salt with a password, because that actually make it so you get a password, the password field, which is the possibility for a password, times the salt field of possibility. Yeah. So in cryptography, this is actually something which is well known. So you get way more possibility out of possible. Actually, this is a Cartesian project. This is not a multiplication, but anyway. So yeah, in feature there is some stuff. You have so encrypt seed plus salt. In our case, encrypt is actually using X and Z, or chunk X and Z, and then usually we add the salt at the at the end because we use something which is called linear and not actually polynomial. But yeah, the principle is quite similar anyway. Okay, so that's the structure. So for structure, the main stuff which are missing are some of the generator. So for example, there is only those one, but soon there will be more of them. So yeah, the device is to actually get. So if you, for example, have multiple structure, you can actually crack the structure seed from multiple structure without actually iterating through all the seed. There is actually some properties on the upper bits which actually give you, if you say for example there is a village at this place, and this place, you put them in structure device and you can actually get the structure seed in like a few seconds instead of brute forcing through all the 48 bits. So this is what this device make. It's not stable, but it works. Yeah, but there is still some research in that field. So yeah, anyway. So in miscellaneous, you get the slime chunk. So this one is to get the state of a chunk, if it's a slime one or not, and spawn point to get actually the spawn. So you can get the average, so the approximate point depending of only the biome, or you can get the spawn point exactly with the terrain generator. So this one actually generates a full column to actually get to check if it's possible, and because of that, then yeah, it's quite slow, but it's accurate. For now, it's not fixed, but it will be fixed anyway soon. Then you have the loot. So the loot is in feature because it's also kinda, well, it's related to features, so we put it in feature util. Maybe we should create a loot util, maybe someday. I don't think so, but anyway. So here you have also loot table. So the loot table, what are used for generating. Yeah, it's actually a tour of all the utils. I will actually post a video at the end, so if you want to watch it from the start, you can actually watch it afterwards. So the loot table are what you use to actually generate a chest. So here you can see that there is a different pool, and in different pool you choose one item per roll, and the item is depending of the weight, and you can actually get between some range of item for each roll. So yeah, that's how loot table is done. The loot table is well, the utility to actually use the loot table. The loot pool is, yeah, loot generator is how to generate a loot. The loot context is the general seed. So you set a seed for getting a loot, and you store it in the loot context, and then you call the loot context everywhere. But usually you don't use the low method. You actually use the higher one, which is in iLoot. So in iLoot is an interface which is implemented for each of the structure which support it, and you can call getLoot with a structure seed generator. So that's actually a generator for the structure, and then run a boolean saying if the loot should be indexed or not. So to get some context, indexed means that if the loot should be spread in a chest or should not be spread. So if, for example, if I look for here, here I can call spread. So this is indexed. So that means that each of the slot have some number attached to it, and you have the item which are spread into this number, or this is not indexed. So it's just like all the possible item in a chest. So yeah, it's just a list, for example. Yeah, everything will be used in the SeedFinding episode 2 about the loot. So yeah, this is the implementation. It's quite useful to get the loot and so on. So you can get some loot at some position, for example. So this is a higher utility which actually use this utility and give you a list of chest content. So a chest content is basically, yes, a chest like that with a list of item, and you can check if it contain an item or not, and so on. You can check if it's a double or single chest and so on. And here you have also utility to get the loot and compute the loot. So you have the enchantment, the effect, and so on. You have the item. So there is two type of item. There is the item which is a single item, which are here also possible item are here. And there is item stack, which is an item but with the count of a number of items. So it's actually a stack of item, that's the name, and you have so item plus the number. And in item you can also store some enchantment as an effect. So for that there is actually two utility. So you can check if it's equal, so if item is the same, or if it's equal by name. So actually I think I forgot to update my Futuritial. That's why there is a new let me actually check my utility here. Oh yeah, I'm not up to date. Here you have equal name, so you can check the no, so the item will not be moved yet to MCTL for one reason yet. They are not fixed for all version. So since mostly they are used for now in the loot and not in anything else, they will stay here. Yeah, for some time. But once they are version dependent, they will be moved to MCTL. For now, they are staying in Futuritial. I try to keep at minimal change in Futuritial, but sometimes I have to do them. So yeah, but soon they will change. Yeah, and here you have the function for loot. So that's the loot universe. You mostly use this method, so get loot at position or get loot here, and yeah. This is only implemented for all the structure which have a generator. So for that you call generator, you get the generator, and then you call get loot on the structure. We'll see some example later on. Then there is a decorator. So the decorator, they have different type of decorator. So there is the main one, which is depending of the biomes. So the decorator have some data, which is mostly the index, step, and salt. So salt is actually computed from the index and the step, which is just the system in which Mojang since 1.13 works, well actually Mojang use, um, and it's basically they have a different stage of the generation, and in each stage they have an index for all the decorator. And because of that, if you change the order in which the decorator happen, the index change and so on. So you need to have some kind of config to actually sort them depending of the version and so on. And for the data, you can actually store the chunk X and Z, because most of the decorator only depend on chunk position and the biome. And also you can check if it can start. So usually you set the decorator seed. Maybe you can like check some condition here, and then you can check if it can be spawning here. So you check the biome and if it's valid and so on. There is not yet can generate here because for now, there is no use to have in decorator. It's already in feature and it's solely implemented per decorator. So this is an abstract class. Then you can actually implement different decorators. So here are two examples, and gateway and desert well. So they implement what we call a biomeless decorator, which is a specific decorator which not depend actually of the biome. So some decorator actually depend on the biome, some doesn't. So for desert well and gateway, they don't. What I mean by not depending of the biome is actually quite complex, and I want to actually clarify it. So, a decorator can only spawn in some biome, so that's like structure and stuff like that. But they can actually depend of the biome in some other way. They can actually depend of the biome in the index step I told about before. So for example, they could have a different salt depending of the biome. So for that we use what we call a config, and in the config we can say, for example, that depending of some biome, they should have a different salt, which will be used in the later stage to actually generate them. And so for desert well and gateway, this is emerald all, for example, depending of biome. I will No, it actually not depend on the biome. But I will go to the ore later on. So, for example, for desert well and gateway, can only spawn in some biome, which are mostly the end island, but they actually don't have any predisposition to other biome because they can only generate in some biome. So you have only one index and step possible because in that biome. In desert well, it's the same. Well, it's a bit different because they can generate actually in free biome, but in all the free biome, they all arrive on the same order in all the different biome. So they will have the same salt in all the different biome, which is not the case for all the decorator. So let's go to the ore decorator, which were introduced quite well recently. And for example, let's go to the clay disc, which is a full decorator. And for this one, for example, you see that it actually can spawn well in all the possible biome which are valid for this one. So actually, it's all the biome. Actually, I should specify that one, but anyway, normally you can generate everywhere, but there is only some which actually use it. But anyway, um, so you can see that for most of the biome we have index and step of 12 and 4, but for swamp hill and swamp we actually need to override it because it's different, and that's because there is no over disk in that swamp and swamp hill, so it's not possible to get the gravel disk and the sand disk in the swamp and swamp hill. So if you go in the sand disk, you will see that is valid biome. We actually override it and we say that it should not be a swamp, of course, because if it's a swamp, then yeah, it will generate. So we don't want them to generate, so we exclude them from the valid biome. So one question was, is emerald ore depending on the biome? So if you go here, you will see that actually it's not. It's valid only in some biome. So it's valid only on mountain edge, mountain and so on. But for all of this biome, actually, it's the same salt. And if you want to actually get all the different salt, I put a pin in my Discord, but also it's in Monkeys and a lot of stuff, and also well, it's in on my GitHub. So if you go in my gist, you will see that I have a list of all the salt. So if you go for emerald, for example, my bad. Let's go to 1.17 because 1.13 doesn't have the exact name. So emerald here, you will see that it's always the same salt because it's always at the end of the stuff. But in only generate in 5 biomes in total and not in all the biomes. So here the salt list should be read as so there is one biome here, biome ocean. Then there is multiple stage, so structure, road generation, lake, local modification, underground structure, surface structure, stronghold, underground ore, underground decoration, vegetal decoration, top layer modification. Then there is a new biome, and there is different type of decorator depending of the biome. So that's why there is different type of salt. Okay, so now that we saw that there is salt and stuff like that, I think it's time to see how you could improve on feature util and other library. So what are currently missing in those library are really specifics. Salt is what Matthew use. No, Matthew actually use. Well, it uses the salt to compute that, but it actually uses the fact that so if I go back to my list, I need to actually go back here. Let me get the 1.17, 1.16, my bad. It actually used the fact that this clay disk is generated a few call after the diamond ore. So because of, well, not a few call, but the salt is close to the diamond ore. So because of that, we can actually see that if we get a clay which is offset by some amount, then we know that the diamond ore is offset also by some amount compared to the clay. and this is because they all use the same method, so they all set the same seed with a different salt, but because it's the salt is like I said, used in a linear manner and not actually in the encrypt method. So if I go back to my analogy, so encrypt password plus salt, this is what you should do in production. Well, not actually that, but if you want to do it in correctly, you should at least do that. That's a minimal, salting your password. But anyway, in Minecraft, you actually do encrypt password plus salt. In password is actually seed, and seed you actually encrypt it with the X and Z. Well, chunk X and chunk Z, and you add the salt. And because of that, if the difference in salt is actually like a +2 or +3 or something like that, then because they use all the same method and then to compute the position of their decorator, you can actually use that to actually compute the difference in block in which some decorator will spawn. So that's what Matthew used to actually compute the offset to get the diamond. Okay, so how to improve it? There is a few stuff which need to be improved. So if I go back to my schematic here, so in Nosotile there is not much to do. Biomaterial, there is alpha biomes, which should come soon. There's also the GPU biome, which will come soon also. And there is the part about area generation, which is actually on a separate branch. So if you got in biomaterials, you will see that there is a biome called new area. This is actually the branch I'm working on. Then in Terrantials, we need to actually make the test for all the version below 1.11. So currently everything up to 1.11 is tested, but below is not tested. So it's supported to 1.8, but actually 1.8 to 1.11 is not fully tested. And then actually I need to support everything down to 1.0 and then alpha. In FutureGL, there is a lot of decorator which are missing. So if you look at what we call at the Minecraft source code, you will see that there is around 200 decorators. And if you actually look at the salt, I should actually have it pinned. You will see that there is a lot of different decorator. So for now, the underground ore are set. The underground structure, dungeon is not actually implemented in FutureGL, but actually is implemented in another library. I will show you afterward. In local modification, there is nothing which is important. Surface structure, they are all implemented. They are also big structure. Stronghold, they are implemented. Underground ore, which say they are implemented. Underground decoration, I actually don't recall what is underground. Oh, it's an infested ore, a stone. I don't think we have yet them. Well, it's really easy. You just need to add them, add the salt, and that's it. The vegetal decoration, it's one part we didn't yet do. So you have all the random one and the flower. So that part is actually needed to be worked on. The top layer modification, you need to maybe to do it, but it's not really important. The issue with the stage decoration, they actually depend a lot of the part above. So they depend of the terrain, but they also depend of other decorator or structure which could modify the value of the Y value, and so because of that, you actually need to store all the you need to generate the full structure and store like the position of each block to actually generate like the vegetal decoration. So that's quite annoying. So for now we don't have them because we don't feel like it's needed, but we have like an implementation for the trees or stuff like that, which we use, for example, for cropping. So there is a question about how to implement the dungeon, and my answer is quite simple. You actually go on SyncCracker. You can actually see it in different repository, but for I think SeedCracker is the main one. So if you go in Cracker and in Finder and Decorator, you will see that you have a few stuff which are here, and you will see that the Dungeon Finder is actually here, and my bad, it's not actually here, it's in Cracker Decorator. Here you have actually the dungeon, which implements the decorator template, and you can see you have all the implementation of the dungeon here, and how to actually crack it, but anyway, it's not really relevant. So technically you just need to copy all of that. Yeah, and yeah, that's it. You actually have implemented the dungeon. So that's really easy. I mean, yeah, there is not much. Um, but yeah, so dungeon is a biome decorator. So it depends actually, the salt depend of the biome. Here you can see there is actually an override for swamp hill, but there is also dependency for desert and swamp. So yeah, so for dungeon that's really easy. You can just add it here. There is not much to do. I mean, I could add it, but right now I'm not doing that because I'm working on other stuff. Anyway, yeah. So yeah, if you want to help, well, there's a vegetal decoration, and yeah, there is a few stuff like well, dungeon, but yeah, it's a few lines to actually copy over. Also, there is a test, and there is also the structure generator, which are missing for a few structure. So yeah, that's about it. A lot of stuff I actually done in those library, and yeah. So last step I think is how to actually look at Minecraft code. So what I did is actually I have a library, which is Minecraft, uh, which contain all the different version of Minecraft here. So you have all the version of Minecraft, and I can actually run them directly because they are just like the source code and the library statically. So there is nothing which I need to download. And then I have my Gradle, which is simple. Basically, I use the library, the local library, and I call my start, and then I can actually run my Minecraft. So if I call start, let me see, maybe actually I modify something. Maybe it's not correct. No, my bad. It will actually start. Let's just compile it. It might take a while. So yeah, that's how usually you go about looking at code. You usually use the compile source, and you can run it, stuff like that. If you want to quickly decompile stuff, you can actually use the compiler MC if you want. So you will have like the full source code, but it's not executable. So you can just look for stuff, or you could look for diff or stuff like that. So yeah, it should be quite soon able to run. So as you can see, it takes about, well, 1 minute to compile. Then it can start. So yeah, there's a few stuff related to authentication, but then actually I get a standard Minecraft, and I have it for, yeah, all the version back to actually beta, so I can run beta here. I have if I look at my build Gradle, it's very simple, just a start method. It's like any library or stuff like that, or any application, just Minecraft as an application. And I can create a world or stuff like that. And the useful stuff is usually you run it in debug mode, you set up like well, a breakpoint, and you see what are the value at some point to actually debug it. So yeah, that's about how I do my stuff. If I want to do some specific stuff like making tests or stuff like that, I actually dump everything from Minecraft directly. So I dump them into a file or something like that, and then I can use them. So yeah, for example, we are in debug mode. So if, for example, I call main, let's go in world, uh, let's go in uh, gen, then let's go in chunk generator, for example. Uh, what can I stop on? For example, apply biome decoration. So if I create a new world, you will see that I will be, yeah, I will hit here, and I will get like all the value I want and so on. So I can, for example, test that the seed is actually correct, and so on. And yeah. So to add the random patch, so first you want to actually get the feature you want to work on. So for example, you said you want to work on pumpkin. So pumpkin, pumpkin. Where is pumpkin? Pumpkin. Oh, it's not here. So pumpkin. Is it named pumpkin? Pile of pumpkin. Patch pumpkin. Here. So it's a random patch. So you need to implement a random patch decorator, which is basically yeah, this one. So it's quite annoying because it needs to use get 8map, so you need to actually get it. But this one is actually easy. It's a pre-gen one, so you just call get word height on ground. Then you can yeah, then you actually need to get all the block state beforehand to be sure that actually it's not yeah, a specific block state which impedes something. So yeah. Oh yeah, I forgot. Yeah, we need actually to generate the cover like ravine and stuff like that also. I forgot about them, but yeah, they are also not currently in feature till, but they will be soon. So yeah, you need to implement a random patch. Then you can go in here, and then you can go here, which is basically the configure stuff. So it tries 64 times to generate it with the random patch feature, and it uses the 8map double square method, which is basically to check if the 8map is correct. And yeah, that's it. You just need to actually implement it as well. The get placing that will depend of the random patch, and yeah, I mean it's not really hard if you have the ground stuff. The issue for the vegetation is mostly you actually need to have the previous block because they actually highly depend on them. But yeah, except that I could provide like an implementation for a random patch, and then you could just like adding the ore. If you look at the feature tier, currently the ore are mostly one big decorator class, which is ore decorator, which is generating the position. The config is getting well, is getting everything. Then there is the regular ore, which generates the ore position, generates the vein part, and yeah, each of the ore afterward is just like a few config. So you get the salt, you get the biome requirement, and so on. And yeah, that's it. That's about it. Some are quite complex. For example, yeah, you have like a lot of salt and so on. But yeah, that's about it. Yeah, so I think that's about it. That's a walkthrough of the library and how to do stuff in them. So if I wanted to make a list of stuff which are needed currently, so first one, which is asked a lot, is a finished jigsaw. So finish jigsaw. Then there is add well, some decorator. So that would be a dungeon, for example, but that would also be the carvers. So that would be, for example, the ravine. There is also the cave, which are important because the cave actually are used for the dungeon. Then you actually want maybe to have the terrain for 1.8 minus. There is biome for 1.18, but this is actually finished. Well, it's work in progress. So for loot generation for dungeon is actually a bit tricky in some way. You actually need to generate the full floor and check that there is a block actually placed correctly. So in recent version it's actually really easy, but in older version it was a bit tricky. So if I go here in Minecraft and look for monster room, here, monster room, dungeon feature. So as you can see, it uses a place. So here the place is actually you have a random object which is seeded with the decoration seed at the beginning here before calling place. So each place method is called with the decoration seed set. Then you have two next int to burn. Then you have the floor size to burn the next int. So that's here, the next int for here. Then you have the next int for the wall to burn, and then you have here the the set loot table, which is using the seed. So when you call set loot table, actually it sets the loot table with the next long of a random seed. So what you want is actually get the structure seed, burn all the necessary call, and then here get the next long and store it. And for that we usually, if you look in Iterator, in how we do it for other stuff, is so generator here structure. So you want to return here generator. You want to return the get loot position as simply just the chunk position of the dungeon after being sure it's actually generated. So you need to generate the cave. So that's actually strong stuff. So you need to generate the cave, generate the dungeon, then you get the loot position, and you need to put in the decorator. You need to implement the iLoot interface, and if you look in shipwreck here, so it implements iLoot, and you need to override the specific call, which will actually use a generator and a random, and you will actually here skip all the necessary call before actually setting the seed. Yeah, and yeah, that's about it. So that's not really hard. You can basically just yeah, it's not hard really. You just need to copy the stuff, implement iLoot and so on. The hard part is actually coming from something else, which is cave. The cave are not implemented, and without that you actually are stuck because dungeon heavily rely on cave. So without a cave generation system, you cannot actually generate accurately dungeon position. You can get all the dungeon position, but you cannot know which one will actually be valid and generate. And which is important because they generate in a specific order, and because of that, you have like so you have 8 dungeon which are generated. So let me get paint. So here you have a full chunk. You have 8 dungeon position which are generated in the chunk. Only some which are below the sea level are actually generated because they are inside block, and only the one which are near a cave, for example, are generated. So they need open air and some block to actually generate. And when they generate, well, it could be any of the 8, so they could have some offset, and because of that, well, yeah, it's a bit annoying to actually generate them. So, well, generate the loot from them, because you need to be able to know which one was not generated, to know which call to burn and which not to burn. So yeah, it's a bit annoying. That's why it's not implemented yet. Because if I implemented it, then people will say, oh yeah, but I need to be walking everything. I need the loot and so on. And yeah, it's not trivial because you need the cave generation. So first I need to implement cave, ravine, then you actually you can generate. Yeah, so I think that's about it. Uh, the library are quite complete, I think. They cannot generate a full world, but they can generate a lot of stuff and very fastly. So yeah, that's about it. So it's been 1 hour and 30 minutes. I think that's enough for today. If you have any question, guys, it's a moment. Else I think we should write it. Yeah. Okay. Yeah. So thanks you for watching. Yeah, if you have any question, then you can join me on my Discord and just ping me and ask me a question.